Hi guys, this is Mrs. Tellas. I'm going to go through the notes on power to a power and raise a product to a power. This is day 3 in section 6.1. Okay, so we start here with the rule, and when you raise a power to a power, you multiply the exponents. So multiply, and the base stays the same. So if that's the case, notice how it looks different from yesterday because there's only one base and a parenthesis and two exponents. So what we're going to do is we're going to copy the base down and then we're going to multiply the exponent. So this will be m times n, which is equivalent to a to the mn. That's my answer. So it works for numbers as well. So it's power to a power. There's only one base with two exponents. I copy the 5 and I'm going to do 4 times 2, which ends up being 5 to the 8th power. And I can evaluate that, like if it's question press and I need to put in a regular number because powers are not allowed, I can do 390,625 by typing this in, 5 caret 8. It also works with variables and number combination. So again, I copy the base and I multiply the 3 times 5. So this is m to the 15th power. Okay, so if we go to the next page, there's some that they could try on their own. So this, I copy the x and I multiply 4 times 5. That's x to the 20. Number 5, I copy the base n and I multiply 4 times 7. That's 28. And then number 6 has a little spin on it, but not much. I'm going to copy the base and multiply negative 5 times 4 and get negative 20. Well, he's unhappy because he has a negative exponent. So this goes back to the first section in 6.1, and we're going to move that to the denominator to make him happy. So this is my final answer, 1 over p to the 20. Okay, and it works here too. I don't know if I can move that. It doesn't move. There we go. Same thing here. This would be y to the negative 10 when I multiply. He's unhappy. So I'm going to move him to the bottom part of the fraction. So 1 over y to the 10 is the answer. Here, same thing. I write down the base and I multiply the exponents. And then I move that to the bottom because he was unhappy. Had a negative exponent. He's unhappy. So we move him to the bottom part. And then on 6c, we're just multiplying w. 7 times 3 is 21. He's happy there. I don't move him. And then number 6D is the first one where we have a power rule and a product rule. So we're going back to what we did yesterday. So first we'll do this part because PEMDAS says you must do exponents before you do multiplication. So this r to the third is multiplied by the answer to this. So I'm going to drop the r to the third times. This would be r to the negative 5 times negative 2, which is 10. So this goes back to the rules from this morning and yesterday where we are adding the exponents. So my answer there is r to the 13. So notice in this problem I did a power to a power here and got that answer. And then I did a multiply problem, so when it has the same base I add the exponents and I ended up with r to the 13. Here is another power to a power right here. So that's y to the third. I just copy that. 5 times negative 2 is negative 10. This is a multiply problem, so I'm adding the exponents. So y to the 3 plus negative 10 is y to the negative 7. He's unhappy, so we move him to the bottom part of the fraction. So 1 over y to the 7 is the answer. The other two are just like them, just different letters and different numbers. I'm going to start with power to a power. I copy down the x squared, and that would be x to the negative 24. This is a multiply problem with like bases, so I add the exponents. So 2 plus negative 24 equals x to the negative 22. And he is unhappy with a negative exponent, so again I move that to the bottom part of the fraction, the denominator, and that's my answer. Number 9 is just like it. Okay, so I'm going to do the power to a power first, this part. So y to the negative 2 gets copied because that's the multiply part of the problem. This is power to a power. That's w to the 21st. And then I would add those together because now it's a multiply problem. So my answer ends up being w to the 19. It does not go to the bottom like the previous one did because it has a positive exponent. Number 10 is just like 7, 8, 9, except it's got the r to the third at the back rather than in the front. So I'm going to go ahead and do the power to a power first. That would be r to the 10 times r to the third. Okay, and I could have put this up here if I wanted. I didn't have to leave it in the back because you can change the order of multiplication because of the commutative property. So now that this is a multiplication problem, I am adding them, and I end up with r to the 13 as my answer. That does not belong there. All right, so here are the other kind when we raise a product to a power. So that means there's more than one item inside the parenthesis. So here there's an AB and here there's a 3x. There could be multiple items in here if it's a raise a product to a power. We still multiply the outside power by each one on the inside, by each exponent on the inside, and the base still stays the same. So you can see on that first example, if there is no exponent, there is a 1 for each of these. So I copy the base A and I do n times 1, which is n. I copy the base B and I do n times 1, which is b. And this would be the answer because that's not going to go in the calculator. So if I go over here, again, there's no exponents here, so these are both 1. So I copy the base. 4 times 1 is 4. I copy the base, and 4 times 1 is 4. I can go ahead and multiply 3 to the 4th out. I'm just going to stick that in my calculator real quick. 3 caret 4, and that's going to give me 81x to the 4th, which is the final answer. Number 5 is extremely similar. There's a 1 here. Since there's a 2 here, I'm not going to put a 1. It's a 2. So I copy the base, and 3 times 1 is 3. Copy down the x, and 2 times 3 is 6. And then I'm going to put this part in the calculator, 5 caret 3, and that's 125 x to the 6th. Number 4 is similar. There's an exponent on the 7 of a 1, so I copy the base. 3 times 1 is 3. And then I copy the m, and 8 times 3 is 24. 7 to the 3rd power is 343. And that's m to the 24th. And again, I'm just sticking that into the calculator to get that 343. All right, I've got a negative 1 here, which is the same. So the 2 has an exponent of 1, and the z has an exponent of 1. So I copy the 2 down. 1 times negative 4 is negative 4. And copy the z. 1 times negative 4 is negative 4. Both of these are unhappy, so they are going to the denominator, or the opposite part of the fraction. And then 2 to the 4th power goes in the calculator because that can be evaluated, and this answer is 1 over 16, z to the 4th power. Number 6, we got a 1 and a 1 because there are no exponents showing, so that's 4 to the 3 times 1, which is 3. And m to the 3 times 1, which is 3. And then 4 to the 3rd power is 64, and the m to the 3rd stays exactly the same. Okay, on to the last page. Looks like I have 2 number 6s. So I've got a negative 2 out here. The exponent on the 3 is a 1. I copy the 3. Negative 2 times 1 is negative 2. Copy the g. 4 times negative 2 is negative 8. Both of those are unhappy and need to go to the denominator, or the opposite part of the fraction. And then 3 to the 2nd power is 9. So it's 1 over 9, g to the 8th power. Same for the second. I'm going to put a 1 here with this 5 because there is an exponent there. We just don't write it usually. So 5 to the 1 times negative 3 is negative 3. Write down the a. Negative 4 times negative 3 is 12. He's perfectly happy. The 5's not and has to go to the bottom part of the fraction. So a to the 12 stays on top. 5 to the 3rd goes on the bottom. So that's 125 on the bottom, or in the denominator. Okay, here I'm going to distribute this -4 to both of these by multiplying. I don't need to put a 1 in there because they both have their own exponents. So x to the -3 times -4 is just 12. And y to the 6 times -4 is -24. He's unhappy. He needs to go to the bottom part of the fraction. So that's x to the 12 over y to the 24 as the answer. Okay, so they're getting a little longer now. You can see there's multiple parentheses. So I've got power to a power here, and I've got a product to a power here, which is the same thing. Okay, so this part right here would be n to the 10. I just multiplied 5 times 2. The 4 has a 1 exponent, and the m has a 1 exponent. This is a huge multiplication problem. So 4 to the 1 to the third, I copy the 4. 1 times 3 is 3. Copy the m. 1 times 3 is 3. Copy the n. -2 times 3 is -6. Okay, normally the numbers in the front, 4 to the third power is 64. So I'm going to go ahead and put that in the front. The coefficient goes in the front. Alphabetically, m is next, and he's perfectly happy next to there, m3. And then these two, n to the 10th and n to the -6, are their own little multiply problem. So I'm going to add 10 plus -6. That's going to give me n to the 4th power. Everybody's happy? This is my answer. Okay, you've got power to a power here and here. The exponent on this x is a 1. Everybody else has their own exponent. So this would be x to the -4 for that first term, multiplied by x to the +4, because I multiplied 1 times 4. And that last piece is y to the 20, 5 times 4. These two are a multiply problem because they have the same base. So x to the -4 plus 4 is x to the 0. X to the 0 equals 1, so my final answer is just y to the 20. And you could write 1y to the 20 if you wanted. That would be exactly the same thing. Okay, I've got some exponents in here, a 1 for the 6, a 1 for the a, and a 1 for the b, and also a 1 for the 5. So we'll do this part first. Copy the 6, 3 times 1 is 3. Copy the a, 1 times 3 is 3. Copy the b, 1 times 3 is 3. The first parenthesis, power to a power, is done. Then back here, and these are all multiplied. So 5 to the 1 times 2 is 2. And a to the -3 times 2 is -6. So I'm going to pull the numbers out and put them in the front, okay, because the coefficients are always numbers. So 6 to the third times 5 squared. Okay, then a's would be next, this one and this one. So that's a to the 3 plus -6, which is going to be -3 in a second. And then I'm just copying the b. So I'm just getting them in the right order, combining those a's. So I'm going to stick this part into the calculator. 6 to the third power multiplied by 5 to the second power, and that gives me 5,400. These two, a to the -3 and b to the third, again, he's on his own. He doesn't have anybody to multiply with. And then the last part of this would be to make the a happy. So 5,400 b to the third over a to the third is my final answer there. And looks like I'm all done with power to a power and raise a product to a power. I hope this video was helpful for you. If you have any questions, come see me or shoot me an email. Thanks.